My name is Rob Fatland. I'm a research computing director at the University of Washington. And before we get started on the Cloud Bank perspective, there's just a couple of things that we'd like to mention about how things will be working. So first of all, again, thank you on behalf of Cloud Bank for attending our inaugural exploration of research computing on the cloud. And the way that the RRoCCET21 conference will work is we're going to be running Tuesday, Wednesday, and Thursday of this week from 9 a.m. to 1:30. Today, we'll start with a perspective from the Cloud Bank organization, and then we'll move from there into case studies, which is our main mode of proceeding. And then in the last session of the day, we'll have a Here's How session from Clayton Barlow at Azure. So each day will feature a closing session from the cloud providers themselves on how to do things on their respective clouds. We will use one Zoom link for all 3 days, and you're admitted as you were this morning based on your name. We'll use the chat for questions, and we'll ask that you keep your cameras and microphones off to save bandwidth. We have over 140 people attending. And then we will capture questions as they appear in the chat so that when we get to the question and answer period at the end of the presentations, we'll be able to reiterate those. And then lastly, if you happen to be speaker, we'll be using pen clicks as an audio cue to indicate that there's 4 minutes remaining and so forth. So I think that's everything I needed to say at the outset. At this point, what I want to do is share my screen. So I will click down here, present. All right. So now what I'd like to do is begin by sharing our Cloud Bank perspective with you. And this includes where we're coming from, how we originated, and what we're hoping to accomplish in this conference. So first of all, Cloud Bank is an organization that is a collaboration between the University of California, San Diego, University of Washington, and University of California, Berkeley. And we also partner with a company called Strategic Blue. And so in other words, we are academics, and we recognize the value and potential for cloud computing in research. And so we think of ourselves as part of a community, and that's why it says we're all in this together. And I wanted to begin by acknowledging Deep Medi and the National Science Foundation, who arrived at the conclusion that it was really important to invest in the machinery of cloud adoption, and that facilitating this process was going to open doors and allow people to address challenges in computing that are otherwise difficult to meet in the way that data science is proceeding. So a little bit about myself. Since 2015, I have been at the University of Washington. My role has been as a research computing director to be an advocate for cloud computing. And this is similar to what has emerged as the Cloud Bank project. So my job has been happily overlapping with my responsibilities in Cloud Bank. And as facilitating cloud computing at the University of Washington, there's a number of different facets to this. A lot of it involves simply talking to researchers, finding out what they're working on, what their difficulties are, and then seeing if that does map to cloud resources and cloud computing. But we've also actively pursued student cloud use through a student research computing club. And we've also had something that I wanted to mention. We've conducted a couple of surveys in the last couple of years. And the surveys are really interesting because we're surveying researchers at the University of Washington and saying, you know, what are your pain points? What are your challenges? And this has kind of led to this reinforcement of this idea that research challenges are about data, they're about software, they're about collaboration. You know, how do I deal with these things? And they are not really about the cloud per se. So for us, it's important to say that the cloud is a means to an end. It's not an end in itself, So we say cloud a lot and we talk about the cloud a lot, but really we're trying to get to the point where the researcher can get past these obstacles and focus on what they're trying to accomplish in their work. And so this is something that we'll repeat fairly often. I wanted to also present the idea of a research team model as a kind of way of thinking about this. So we have a lot of people attending this morning, and we don't know necessarily where any of you attendees are in your experiences with cloud, how familiar you are with it. So we're kind of assuming that you are leaning in, you're interested, you have some idea what the cloud is. You're not necessarily a cloud IT professional or pro, but you're perhaps part of some kind of a research team, and you have your domain of interest, and you have your whatever your level of IT skills are. You have the methods, the data science methods perhaps that you're using. You have data that you're working with, which exists at some scale, some size, some volume, and some level of complexity. And then you have your existing resources, your compute resources particularly, and this often connects with this is characterization connects with a desperation level, let's say, or if everything's fine to, oh my gosh, we're about to lose a lot of data. We really need to manage this and deal with it in some way. In addition to that, a research team typically has a turnover rate. If you have students coming through, for example, you have a drive to publish, you have funding, and then you have time. And time is really a sort of an important resource from my perspective, because what we're trying to do is we're trying to essentially, sociologically revolutionize how computing is done, and that requires a time investment. So what we're trying to do is optimize a research team's time investment in order to be able to address these computing challenges. And then, of course, you have some level of administrative support. So we consider the cloud use arc out of the Cloud Bank organization as an initial sort of learning process, learning and understanding what the cloud is about. So I'll talk about that in a second. And then kind of 5 steps of cloud implementation, let's say. In broad strokes, this means you want to evaluate whether the cloud is right for you. You want to implement your computing on the cloud. And then once you've done that, you want to take some time and energy into optimizing how you use the cloud. Because if you can do a calculation for $1,000, but you're spending $10,000, then you're going to burn through your funding faster than you need to. Finally, we want to, not finally, almost finally, we want to mention that when a grant award is about to end, you want to have an exit strategy for what are you going to do next. And maybe this means recovering data, this means perpetuating data in your compute environment on the cloud. However that happens, because Cloud Bank is a organization that helps you get on the cloud and use it effectively, part of our responsibility, we feel, is to help you develop an exit strategy before you get to the end of that project and start thinking, oh no, what am I going to do now? And the last thing that I wanted to mention is in quotes ET at the bottom here. And you'll notice that ET is the last 2 letters of RRoCCET, our conference name, and that stands for Emerging Technologies. And this again comes into optimization, because what we want is for you to know about services available on the cloud that can make what you're doing easier. So services I'll talk about, and emerging technologies and services are kind of roughly equivalent, but basically we have this vast ecosystem of scientists and engineers and researchers who are developing tools. And as those emerge and are built on top of one another, there has to be some kind of way of connecting to them and knowing about them. So Cloud Bank is trying to become sort of a knowledge resource or a procedural resource that we can direct people to solutions that help them get stuff done better. So that's the ET in RRoCCET, the emerging technologies. Okay, so I mentioned that the first step is to learn about cloud, and I'll just give a quick example of how to learn about cloud thinking by invoking a researcher, the stick figure person who's busily typing at a laptop. And they're thinking about their compute task, and their compute task has some size to it. And so let's say it's a big compute task, and they're thinking about it, and they look around, and of course, there over in the corner is their usual computer. So they set up their job to run on that computer, and it runs for a while, and it does this much of the compute task, and it runs for a while longer, and now it's done 4 blocks of the compute task, and so on. And then the researcher looks at the wall, and they notice that a few days have gone by, but the task isn't done. So what do? You keep running, and you keep running, and so on. So that's the traditional model. You take the compute resources you have available, and you start your task, and one eternity later, hopefully it all finishes. So thinking about the cloud, now we have to pivot and think about, well, the cloud is a very large number of computers, and I can allocate a bunch of them. So now I can look at the clock and distribute my computing tasks across all those computers, those virtual machines, and lo and behold, my job is done in much less time. So that's like step one in cloud thinking. And there are many other aspects and facets to this. But that's the basic illustration of the process of learning about how to think on the cloud. And as I said, we're talking about pivoting into emerging technologies. So for example, there's opportunities to manage these resources since they're scaling up using things like schedulers and containers and container orchestration. That's something called Kubernetes you may be familiar with or have heard about. Then there's getting into things like serverless computing. And then finally, treating your computing infrastructure as something that you can deploy from code. That's also a big sort of pivot in cloud thinking, and ultimately thinking of the cloud itself as a big programmable computer. So that's an illustration of learning cloud thinking. The term services is used a lot in cloud computing, and there are basically three of them: compute, storage, and networking. So everybody gets that fairly straightforward, but then there's these abstractions, these additional services. So tensor processing units, Azure machine learning, Deep Racer is a really interesting example of something that's developing out of Amazon Web Services. TPUs, by the way, are sort of considered to be natively originating out of the Google Cloud. So a lot of times when we're talking about the cloud in abstract, we don't necessarily call out providers, but CloudBank works primarily with the three main providers, which is the Google Cloud Platform, Microsoft Azure, and Amazon Web Services. And we're also developing a great new relationship with IBM Cloud. So when we talk about the cloud, one of the questions that comes up ultimately is, which cloud should I use? And this is actually a part of the process of learning about the cloud and identifying what will work for you. There's a lot of overlap in functionality between different clouds, and then there's things that distinguish them. So we try and maintain a very sort of non-advocacy perspective in CloudBank. We want you to be able to use the cloud. We don't lean into a particular one, and we do encourage a lot of connecting with the cloud providers to have those conversations and develop a story for your own particular approach. So finally, as a stack of technologies, you have the term infrastructure or cyber infrastructure. That's your baseline computing environment, which then upon that you build abstractions and finesse. And then upon that, you actually get to the data science that you're trying to do. So it's a bit of a process, and we're messaging that as something that we're here to help with. In fact, Sean Strandy likes to say that CloudBank is the easy button for cloud, as a very short elevator speech. But I like to maybe modify that to say that the CloudBank is an easy Swiss Army knife, because we're trying to bring together all the different approaches we can. So CloudBank will conduct consulting conversations with individual research teams. We hold webinars and various other sorts of training. We provide tools and partnership to manage cloud use. So that's a really central idea, and I want to elaborate for a moment. If you apply to, let's say, National Science Foundation under a CloudBank affiliated solicitation, then and you're awarded that, then what happens is you don't become a financial manager of that funding for the cloud part. Instead, CloudBank does that for you, and it provides you a portal through which you connect to the cloud, and through which you can manage your resources, track how you're going through them, and so on. So we'll have a presentation that follows this one very shortly by Shava Smolin, who will demonstrate the CloudBank portal, which is the primary way of connecting to these management tools. Okay, I've mentioned the vendors, or the CloudBank providers, kind of a better term, and that the relationships that we cultivate with them allow us to sort of lean into getting their assistance and their help and their advice. And that can be as simple as a short consult, or it could even be deeper engagements depending on how things are evolving. Then we have what we're calling Cloud Bank solutions, which are taking common challenges and creating little templates or walkthroughs or other resources that allow you to do simple tasks on the cloud that might not be obvious from the outset. We're also developing protocols, for example, to help you with your exit strategy or your data management plan. We're hosting a community forum so that we can connect to one another, and we have a lot of references to existing training materials and other resources. So we want to act as a kind of an information nexus. I want to mention students really briefly. I mentioned them earlier also, but we have the potential for a student to participate in a research program as a kind of a skilled cloud user. And we find that a lot of times students have this great capacity to learn how to use the cloud and can be super contributors to research programs. In addition to that, Cloud Bank is supporting the Berkeley Data 8 data science course, and we'll have a short presentation on that here in this hour also. And that's a class that is developed at UC Berkeley, and it can support a large number of students through a standardized browser-based interface to some data science lessons and exercises and so forth. Okay. And then the last thing I want to mention is that Cloud Bank does not exist in a vacuum. Obviously, we were supported and funded and created out of this NSF vision. And we are part of an ecosystem that is advocating for research computing. Other agencies and organizations that we want to make sure we cite and connect to would include the Internet to Class program, which is cloud learning for department. It's sort of focused for departmental IT personnel who want to use some cloud skills to help their local researchers. And so that's kind of how that's pitched, but it has really the ability to instruct you in using the cloud, and it's a great resource. There are other programs like, for example, PanGeo is a implementation of technologies on the cloud that's oriented towards geospatial research, but has broader applicability in other fields. You have a program called STRIDES at the National Institute for Health, which is sort of analogous in some ways to Cloud Bank. You have national resources programs like RRoCCET and so on. So again, Cloud Bank exists in this larger context, and that's really an interesting thing to try and be able to connect people to resources. So as I mentioned, this presentation will include Naomi Alterman, who is a University of Washington technical education specialist, who will talk a little bit about what it means to be to try and teach some cloud technology out of the Cloud Bank model. Shava Smallin will discuss the Cloud Bank portal, and Eric Van Dusen will talk about the Data 8 program. And then, as I mentioned, the conference will proceed via case studies, where each day we will also conclude with the opportunity to learn from and ask questions of the cloud providers. The last couple slides I have here sort of just illustrate the education, outreach, and training aspects of Cloud Bank. This diagram isn't to delve into, but it is to illustrate how we start running into jargon and then trying to break it down, often in terms of imagery, so that we can start to get our heads around what this technology means and evaluate whether or not it's going to be useful for what we're trying to do. Also, we have a little bit of a common questions theme running through. So cloud security is an example, and these are the kinds of questions that will emerge. And this is the kind of thing that we want to be able to provide answers to, so that people can say, well, I'm not sure about security on the cloud, but I know I can go to Cloud Bank and they'll either give me answers or they'll point me in the right direction. And I think this is the last thing I have to point out, is the incredible value of having a repository as a basis for your code. So I had early in my tenure at UW, I had a graduate student named Tim Durham come to me and say, I understand you're the cloud advocate. What can I do with my project? And I said, Well, you can jump onto the cloud and start using those resources, and that was a huge success. It ended up in a publication for on epigenomics in Nature Communications. But furthermore, we hosted Tim Durham's results on the cloud for another 5 years. So it's still being hosted as a way of broadening the impact or increasing the visibility and the reproducibility of the research. So GitHub and in general, sort of the longevity of data options that we have now are emerging, and they're really exciting because they allow us to multiply the value of the work that we're doing. So this is the last thing I'll mention, that the different cloud providers, the 3 main ones that I mentioned, have different ways of providing data sets that they host that are open data sets. So for example, at AWS, there's a cancer cell line encyclopedia. At Microsoft Azure, you can find a Landsat land surface imaging remote sensing Sentinel-2 data set. The Broad Institute works closely with the Google Cloud Platform on human genomics. And so those are examples of data sets that are made public, and that's often becomes a conversation with the cloud provider in the case that you feel like your data set is something that would be good to share with the community. So that's just another aspect or facet of this whole Swiss Army knife view of cloud computing. So with that, I think I would like to stop sharing and turn it over to Naomi. Does that make sense?